Okay, let's talk about NoSQL databases. Basically, they're a different way of storing data compared to the traditional SQL approach. Instead of needing to define everything upfront with a rigid schema, NoSQL databases are much more flexible and adaptable. They come in various forms: document stores like MongoDB, key value stores such as Redis, columnar databases like Cassandra, and even graph databases for managing relationships. The big advantage is that they're often built for scalability, meaning they can handle huge amounts of data and traffic by easily adding more machines to the system. Okay, let's talk about the different flavors of NoSQL databases. You'll quickly discover that they aren't all created equal. First up are document databases. These treat data as flexible, JSON-like documents, perfect for things like user profiles or product catalogs, where you don't need a rigid structure upfront. Then there are key-value databases, which are incredibly simple and fast, storing information as straightforward key-value pairs. Redis and DynamoDB are common examples, and they're fantastic for caching and quick lookups. Columnar databases organize data by columns instead of rows in Cassandra or HBase, and these shine when you need to query specific parts of a massive dataset. Finally, we have graph databases like Neo4j, which are specifically built to represent relationships between pieces of information like connections in a social network. Okay, let's talk about the big difference between SQL and NoSQL databases. SQL databases like MySQL or PostgreSQL are really structured. They use tables with clearly defined columns, almost like a super organized spreadsheet. Think of it as having a very strict format you need to follow when storing your data. On the other hand, NoSQL databases are much more flexible. They don't require a rigid structure beforehand and can handle all kinds of different types of information, things that aren't neatly organized in tables. They scale really well too, meaning they can easily handle huge amounts of data and lots of users. Think about it like this: SQL is great for structured data where relationships are important, while NoSQL excels when you need flexibility and scalability. Okay, let's talk about when you might actually reach for a NoSQL database instead of a traditional relational one. It's not always the best fit. Generally, NoSQL shines when you need really flexible data structures. Think things that change rapidly, or where you don't know exactly what your data will look like from the start. They also scale incredibly well if you have huge amounts of information and lots of people accessing it at once. And there are different types of NoSQL databases, each built for specific kinds of data like social networks that need to keep track of relationships between users or IoT devices sending in constant streams of sensor readings. Okay, let's talk about document databases. Instead of organizing everything into rigid tables like you might see in a traditional relational database, document databases store information as individual documents, often formatted like JSON. Essentially, each document contains all the related data for one specific thing, maybe a user or a product. It's really convenient because it bundles everything together, making it easier to read and update compared to juggling multiple tables. Okay, let's talk about key value stores. They're really fundamental to understanding NoSQL. Basically, it's a super simple database model. You have a unique identifier, the key, and then the data itself, which is the value. It's like a massive dictionary where you look up information using a specific word, the key, and get back its definition, the value. These are incredibly fast for retrieving data because they don't need to do complex searches, just a direct lookup. Think about storing user profiles. Each username could be the key, and the associated value would be an entire profile object with all their details. Okay, let's talk about column family stores. They're a really important part of understanding NoSQL databases. Instead of organizing data like we do in traditional relational databases with rows and columns, column family stores group related information together under column families. Imagine it like folders within folders. Each row can have multiple column families, and inside those families are the individual columns holding the actual data. This structure is really beneficial for dealing with huge amounts of data where you might only need to access a few specific pieces of information at a time, making it super efficient for read-heavy applications. Let's talk about graph databases. They are a really different approach to storing data compared to the traditional tables you might be used to. Instead of organizing everything into rows and columns, they focus on connections, relationships between things. Essentially, we model our data as nodes, which represent individual entities like users or products, and edges that show how those entities are connected. Think about a social network. People are nodes, and their friendships are the edges linking them together. Graph databases shine when you need to understand these complex connections quickly. They are often much faster than trying to piece things together with lots of joins in a relational database. Okay, let's talk about the big names in NoSQL databases. There's a surprising amount of variety out there. We have MongoDB. It's super flexible and really easy to get started with. Then you've got Cassandra, which is built for huge amounts of data and always staying available. Redis is fantastic if you need something lightning fast, often used as a temporary storage space or for sending messages between different parts of an application. Near-Forge is special because it's designed to understand relationships. Think about connecting people on social media. And finally, there's DynamoDB from AWS. It's a really powerful option if you need something that can grow with your business. Okay, let's talk about why NoSQL databases are becoming so popular. Basically, they're designed with a different approach than traditional relational databases. One of the biggest advantages is their incredible scalability. They can handle huge amounts of data and tons of users without slowing down. They're also very flexible. If your data needs to change over time, it's much easier to adapt with NoSQL. You don't need to worry about complex database migrations like you would with relational databases. Performance is often a big win too, especially for simple queries. And finally, they come in all shapes and sizes: document stores, key value systems, graph databases. There's a NoSQL database suited for almost any data type. Okay, let's talk about the downsides of NoSQL databases. While they are super adaptable and can handle huge amounts of data really well, it's important to know they aren't perfect. Specifically, many NoSQL systems prioritize being available even if parts of the network go down, which means you might not always see the very latest updates right away. Also, complex transactions, like things that need to happen all at once and be reliable, can be trickier to manage than in traditional databases. And because there isn't one standard way to ask questions, each type of NoSQL system uses its own language, which means you might have to learn a new syntax for each one. Finally, while flexibility is great, the lack of strict rules about data structure can sometimes lead to inconsistencies if you're not careful about checking and validating your data. Okay, let's talk about eventual consistency in NoSQL databases. Basically, it means that if you update something like a record in your database, it might not be instantly reflected everywhere right away. It's like a ripple effect. The changes spread out over time. While there might be a brief period where different copies of the data show slightly different versions, eventually, everything will converge to the same state. This is often used because NoSQL databases prioritize speed and scalability, and guaranteeing immediate consistency can significantly impact those things. Okay, let's talk about base. It's a really important concept when we're looking at NoSQL databases. Basically, base stands for basically consistent, available, soft state, and eventual consistency. It's a trade-off that NoSQL systems make to prioritize speed and scalability. Instead of aiming for immediate consistency like you might in a traditional relational database, NoSQL often accepts that data might not be perfectly consistent everywhere at all times. It's about making sure the system keeps running smoothly and eventually gets there, even if it takes a little time. It's like seeing a post appear on social media. Sometimes it's right away, sometimes it's delayed, but it will show up eventually. Okay, let's talk about a core difference between relational databases and NoSQL. It all comes down to how they handle data consistency. ACID stands for atomicity, consistency, isolation, and durability. Think of it as the gold standard for reliability in traditional databases. Every transaction has to be completely reliable and consistent. However, NoSQL databases often use a different approach called base. It's based on availability, soft state, and eventual consistency. So, while ACID guarantees that data is always perfectly correct, BASE accepts that there might be brief periods of inconsistency. It prioritizes being available and scalable. It's like this: ACID wants everything to be perfect right now, while BASE is happy to eventually get things back on track. This trade-off is a really important concept when choosing the right database for your project. Okay, let's talk about sharding in NoSQL databases. Think of it like breaking up a really big task among multiple teams to get it done faster and more efficiently. In a database context, sharding is splitting your data across several servers or shards. As your database grows larger, one single server can become a bottleneck. Sharding distributes the workload and boosts overall scalability. It works by using something called a shard key to decide where each piece of data actually lives. There are different ways to do this, like caching or dividing based on ranges. Keep in mind that sharding adds complexity around things like making sure queries go to the right shard, so it's important to understand how different NoSQL databases handle this. Okay, let's talk about scaling NoSQL databases. Unlike traditional databases where you might have to upgrade your server's hardware, many NoSQL systems are built to scale horizontally, meaning they can handle more users simply by adding more machines to the cluster. The key is sharding, which involves splitting your data into smaller chunks and distributing those chunks across multiple servers. Each of these chunks is often replicated too, so if one server goes down, you still have a backup. All this happens while keeping things consistent using systems like Raft or Paxos, though there's always a trade-off involved in balancing consistency, availability, and tolerance for network partitions. Let's talk about data replication in NoSQL databases. It's a really important concept for ensuring your application stays running smoothly even if something goes wrong. Basically, instead of just having one copy of your data stored on a single server, which could cause problems if that server fails, NoSQL databases use multiple copies spread out across different servers or even different locations. This redundancy is what gives them high availability and protects against disasters. Think of it like having backup files for everything you do. There are different ways this can work, with one server acting as the main writer and others just copying those changes, or with all the servers handling both reads and writes. It's something to keep in mind. Replication affects things like how quickly your data updates and whether you need strong consistency or if eventual consistency is okay for your application. Okay, let's talk about denormalization. It's a really important concept to understand when working with NoSQL databases. Basically, it's about intentionally duplicating data instead of relying on complex joins like you would in a traditional relational database. This happens because NoSQL databases are often designed for speed and scalability, and that means prioritizing fast reads over perfectly normalized data structures. When you need to retrieve information frequently, let's say the author of a blog post, it's faster to have that author info right there in the same document as the post itself than to have to run a join later on. It simplifies queries, and it makes it easier to adapt your database as your application grows. Think of it like this: NoSQL databases are often more flexible and forgiving with data structure changes. Okay, let's talk about indexing in NoSQL databases. It's a little different than what you might be used to with traditional SQL systems. Basically, instead of the standard B-tree indexes, NoSQL databases have several options for speeding up queries. Hash indexes are super fast for looking up exact matches but aren't great for range searches or sorting. Bitmap indexes are really good at handling multiple Boolean attributes efficiently. Think counting how many documents meet specific criteria. And then you've got inverted indexes, which are used in text search databases like MongoDB to quickly find documents based on the words they contain. It's important to remember that indexing comes with a trade-off. It uses more storage space and can slow down write operations, so you need to carefully consider how often you'll be querying your data and build indexes accordingly. Don't index everything, focus on the queries you run most frequently. Okay, let's dive into partition keys. They're super important when it comes to making NoSQL databases handle large amounts of data efficiently. Think of them as labels that tell the database exactly where to put each piece of information and how to spread it out across different servers. If you don't pick a good one, you can end up with some servers getting overloaded while others are basically empty, which slows everything down. A great partition key distributes data evenly, is often used in your queries, and ideally stays pretty consistent so the database doesn't have to move things around too much. Okay, let's talk about how we handle relationships in NoSQL databases. Unlike relational databases where everything is neatly organized into tables with defined links, NoSQL gives you a lot more flexibility. One popular strategy is embedding, basically storing related information asterisk within asterisk the same document. This can be really efficient for data that's frequently accessed together, like a customer's entire profile including their orders. Another approach is referencing, where you store ID within one document to point to other documents in a different collection. Think of a user ID linked to an order. They are separate but related through the identifier. And finally, for incredibly complex relationships, especially networks or social connections, graph databases are often a great fit. Okay, let's talk about the CAP theorem. It's a really important concept when we're discussing databases, especially NoSQL ones. Basically, it tells us that distributed database systems can only guarantee two out of these three things: consistency, availability, and partition tolerance. Consistency means everyone sees the same data at the same time, like a bank balance that always reflects exactly what you see. Availability is about being able to always get a response from the system. And partition tolerance means the system keeps running even if parts of it are disconnected. The catch: you can't have all three. NoSQL databases often choose availability and partition tolerance, meaning they might not always have perfectly consistent data, but they are super reliable in case of network problems. Let's talk about the CAP theorem. It's a really important concept when we're considering NoSQL databases. Basically, it says that any distributed database system can only guarantee two out of these three things: consistency, availability, and partition tolerance. Consistency means everyone sees the same data at the same time, like you'd expect from a traditional database. Availability means your system always responds to requests, even if some parts are down. And partition tolerance is just that it keeps running even if there's network trouble between different parts of the system. But here's the tricky part: you can't have all three. You have to make a trade-off. Choosing to prioritize consistency and availability often leads to something called eventual consistency, where updates aren't immediately reflected everywhere. Conversely, prioritizing availability and partition tolerance means you might accept some stale data. Ultimately, what's most important for your asterisk application will determine how you balance these competing needs. Okay, let's talk about transactions in the context of NoSQL databases. Now, compared to traditional relational databases, where you get rock-solid ACID guarantees, meaning all changes happen together or none do, NoSQL often takes a slightly different path. They are designed for speed and flexibility. So, they tend to prioritize availability and scalability over strict consistency. Many NoSQL systems provide eventual consistency, meaning that updates might be replicated across multiple servers, but there's a short delay before everyone sees the latest data. You'll often see single-document operations are very reliable, but multi-document transactions can be more complex and limited. And finally, some databases use compensation transactions, like rolling back changes if something goes wrong, to ensure you get to an acceptable state eventually. Okay, so let's talk about MongoDB. It's a really popular NoSQL database, and what makes it stand out is how it stores data. Instead of using traditional tables with rigid structures like in relational databases, MongoDB uses something called documents. Think of documents as JSON-like objects. They hold key-value pairs just like you'd see in JavaScript. Because of this flexible document structure, it's super easy to adapt to changing needs or handle different types of data all within the same database. Okay, let's talk about Cassandra. It's a really interesting NoSQL database, and it stands out for its design. Think of it as built from the ground up to be super reliable and handle massive amounts of data. It's a wide column store, so instead of rows and columns like you might be familiar with in a traditional database, it organizes data into tables with lots of columns per row. Crucially, it doesn't have a central server. The work is distributed across many nodes, which means if one node goes down, your application keeps running. It also prioritizes availability over immediate consistency, meaning you might see slightly delayed updates in some cases, but overall, it's incredibly robust and scalable. Okay, let's talk about Redis. It's a really cool piece of tech that often comes up in NoSQL interviews. Think of it as a super speedy database almost entirely running in memory. It's not just a simple key-value store like you might expect. It actually supports different data structures like lists, sets, and even hashes, which gives it a lot more flexibility. Because it's so quick thanks to being in memory, it's great for things like caching, but it also offers persistent options if you need to save your data. It's generally categorized as both a key-value asterisk and asterisk document database, though it's really best described as an in-memory data structure store. The flexible data structures are what makes it so versatile. Let's talk about Couchbase. It's a really interesting NoSQL database, and it falls into the category of a document database. Think of it like this: instead of organizing your data into rigid tables with specific columns, Couchbase stores everything as JSON documents. This makes things much more flexible for developers because you don't have to constantly change the database structure when adding new features or information. It's designed to be highly scalable and available thanks to its distributed architecture, and even offers real-time capabilities, meaning data changes can be pushed out instantly. Okay, let's talk about Neo4j. It's a really interesting NoSQL database because it's specifically designed for handling relationships between data, and that's what makes it unique. Instead of storing things in tables like you might with a traditional database, Neo4j uses a graph model. Imagine representing people as nodes. Those are your entities, and then drawing lines connecting them to show friendships or connections. That's how it works. It utilizes Cypher, which is a really user-friendly way to query this interconnected data. So, while technically a NoSQL database, it's actually a property graph database, meaning it's built from the ground up to excel at managing relationships. Okay, let's talk about where document databases really shine. Think of them as fantastic for managing content that isn't always neatly organized, like articles in a blog or the details of products you see online. They're great for content management systems because they can easily adapt to changes in how your content is structured. E-commerce businesses benefit too, handling product catalogs with different attributes and sizes. Mobile apps also use them well, since data structures can change as users upgrade their devices. And if you're dealing with sensitive data from IoT devices, where the information isn't always consistent, a document database is often a really good choice. Finally, they are useful for personalization, storing user preferences and recommendations based on how they interact. Let's talk about where key-value stores really come into play. Think of them as super-fast memory locations for your data. They're fantastic for things like website caching, so when someone requests something, it's quickly pulled from the store instead of needing to be generated on the fly. They also work great for storing user sessions and even tracking items in a shopping cart. Basically, if you need really quick access to relatively simple data, a key-value store is often a smart choice. Okay, so let's talk about graph databases. They're really useful in specific situations. Basically, instead of just storing data in tables, a graph database focuses on the asterisk connections between pieces of information. Think about social networks, how your friends are connected to each other. Graph databases are perfect for modeling those relationships. They are also great for recommendation engines, figuring out what you might like based on who you know or what items you've interacted with. You can use them to build knowledge graphs, which is used by search engines to understand the meaning behind your queries. And even in areas like fraud detection, where tracking connections between transactions is key. The bottom line is, if relationships are central to your data, a graph database is often a better choice than a traditional relational database. Okay, let's talk about how we approach schema design when dealing with NoSQL databases. Unlike SQL databases that require a strict upfront plan, NoSQL offers much more flexibility. It's really important to start by thinking about what asterisk your application needs and how it will be using the data, not designing the database first. With document-oriented databases like MongoDB, we can model our data around individual document. Embedding related information within those documents avoids needing complex joins later on. For key value stores like Redis, the schema is often implicit. You just define your keys and values based on usage. Graph databases are all about relationships, so designing the schema to reflect those connections makes a lot of sense. And finally, remember that NoSQL schemas can change over time. It's good practice to have a plan for managing these updates. Okay, so let's dive into schemaless databases, a really important concept in the world of NoSQL. Basically, these databases ditch the rigid rules you find in traditional relational systems. Instead of needing to meticulously define your data structure before you put anything in, they are much more adaptable. It's like having a box of Lego bricks. You can build all sorts of different things without a set plan. Each document, which is how NoSQL stores information, can have its own unique fields, and the database adjusts to that automatically. This makes them fantastic for situations where your data requirements are constantly changing, or when you just don't know exactly what shape it will take. Okay, let's talk about how document databases handle relationships between data, specifically embedding versus referencing. Think of it like this: embedding means storing everything related to one thing within that same thing. So, a customer profile might contain their address, phone numbers, and even all their past orders right there in the profile document itself. That's really simple for queries if you need all that data together. However, it can lead to some redundancy. If you update an address, you have to update it in every single customer profile that has it. Now, referencing is where you keep related information in separate documents and link them using ID. So instead of putting the order history inside a customer's profile, you'd have a separate orders collection, and each order would contain the customer's ID. This avoids redundancy, but can make queries more complex because you might need to join data from multiple collections. Ultimately, it depends on how frequently you access that related data and whether you're dealing with large datasets. Embedding is often good for frequently accessed small relationships, while referencing is better when those relationships become more complex or the data gets really big. Okay, so let's talk about consistency in NoSQL databases. It's a really important topic for interviews. Because NoSQL systems often focus on speed and scale, they don't always guarantee the same level of immediate consistency as traditional relational databases. The key here is to understand that many NoSQL systems embrace eventual consistency, meaning data might not be instantly synchronized everywhere. But you need to figure out what level of inconsistency your application can tolerate. Then discuss strategies like conflict resolution, things like last right wins, or even creating custom rules for resolving conflicts based on the specific data you're working with. And if a system offers transactions, explore how they work and their limitations. Finally, consider read your writes, which is a technique to ensure users always see the latest version of the data. Okay, let's talk about secondary indexes in NoSQL. Think of them as shortcuts. They're like creating an index card for a particular field within your documents. Because NoSQL databases don't always have the same rigid structure as traditional relational ones, we need clever ways to speed up searches. Secondary indexes are built on top of fields that aren't necessarily the primary key. They let you quickly locate documents based on values in those other fields. So if you're constantly searching for products by category, a secondary index on the category field can dramatically improve your query speeds, preventing the database from having to check every single product document individually. Okay, let's talk about how queries run differently in SQL versus NoSQL databases. SQL databases, the ones you probably know from traditional relational systems, they're really good at ensuring data accuracy and making sure transactions are reliable. But when you start combining lots of tables together with complex questions, things can slow down quite a bit because of all those join operations. Now, NoSQL databases like MongoDB or Cassandra take a different approach. They prioritize speed and handling huge amounts of data. They often avoid the need for those joins altogether by duplicating information within each record. It's called denormalization. And they use clever indexing strategies to make queries super fast. So, SQL is fantastic when you need rock-solid consistency in complex transactions, but NoSQL really shines when speed and scalability are top priorities. Okay, so let's talk about security when it comes to NoSQL databases. They're different from traditional RDBMS systems, and that means you need a slightly different strategy. First, authentication. Think strong passwords or API keys, and make sure access controls are really tight, with ACL defining exactly what each user can do. Then there's encryption at rest. Encrypting your data is non-negotiable. Don't forget network security. Secure your database servers. Input validation is also super important. As NoSQL databases often take in a lot of user data directly, you have to sanitize it properly to prevent issues. Finally, set up robust auditing and monitoring so you can spot any unusual activity or potential threats. Okay, let's talk about TTL, time to live, and how it plays a really important role in NoSQL databases. Think of it like an expiration date for your data. It's a timestamp you add to each record that tells the database exactly how long it should stay valid before it gets automatically deleted. The database then periodically checks these timestamps, and any records past their TTL are removed. This is super helpful for things like session management, caching, or tracking events over time, anything where you don't need historical data forever. Okay, let's talk about backing up and restoring. NoSQL databases are a slightly different beast than traditional SQL databases. The method really depends on the specific type of NoSQL you're working with. For MongoDB, we often use tools like MongoDB Compass or MongoDump to create snapshots alongside MongoStore to bring them back. Cassandra utilizes tools like NoTool Snapshot and NoTool Recover, designed for its distributed architecture. And DynamoDB? AWS Backup is a great automated option, or you can use the API directly. Remember that many NoSQL databases operate on eventual consistency, so be mindful of how that affects your backup strategy, and always test those restores. It's crucial. Okay, let's talk about how we ask questions of NoSQL databases. Unlike SQL, where you're used to structured queries, NoSQL databases use a variety of languages depending on the type. For document databases like MongoDB, you often write queries using JavaScript-like syntax. It's really flexible and lets you store data in different ways. Key value stores are super simple. You just look up values by their keys. Column family databases such as Cassandra use a language called SQL that's similar to SQL but optimized for how they handle data across multiple servers. And then there are graph databases like Neo4j, which have their own specialized query language called Cypher, perfect for exploring relationships between things. Okay, let's talk about MapReduce. It's a really powerful way to process huge amounts of data. Basically, it breaks down the work into smaller chunks and spreads it out across multiple computers to speed things up. Think of the map phase as taking your raw data and turning it into label pieces. Then, the reduce stage groups those pieces together and does some calculations to give you the final answers. Many NoSQL databases, like Cassandra or MongoDB with its aggregation pipelines, are built on principles similar to MapReduce, making them great choices for handling massive datasets. Okay, let's talk about how NoSQL databases deal with the lot of data, specifically unstructured data. It's a really important question in any interview. Unlike traditional databases that need you to define everything upfront, NoSQL systems are much more flexible. They often don't have a rigid structure like tables with predefined columns. Instead, they use things like document stores, where each piece of information is stored as a document, think JSON or something similar. This lets them easily handle data that changes and has different fields. You might also encounter key value stores, which are super simple for tasks like caching. And then there's graph databases, which are great at showing relationships between pieces of information, like in a social network. Finally, they use techniques like sharding to spread the data across multiple servers, allowing them to handle truly massive datasets. Okay, let's talk about polyglot persistence. It basically means using different kinds of databases within a single app. Think of it like having a toolbox with specialized tools. Instead of sticking with just one database type, you choose the best tool for each specific job. Maybe you need a super fast option for caching, or a really robust system for handling lots of writes, and that's totally fine. It's all about optimizing your application by leveraging what each database does best. Okay, so let's talk about when NoSQL isn't the best answer. It's not a one-size-fits-all solution. If you need rock-solid consistency like in banking or anything handling money, NoSQL can be tricky to manage without adding a lot of extra layers. Similarly, if your application relies on really complicated transactions with multiple steps that need to happen together perfectly, NoSQL might not be the ideal choice. And if you already have a very strict, well-defined data structure that changes infrequently and requires strong guarantees about data integrity, sticking with a relational database could simplify things considerably. Finally, think about reporting. Complex queries involving lots of joins are often easier to build in SQL databases than in NoSQL systems. It's really about understanding the specific demands of your project. Okay, let's talk about where NoSQL is headed. It's not just a fad, it's a core part of how we build modern apps. The biggest shift? Cloud-native options are becoming increasingly powerful and easy to use, with major cloud providers offering fully managed services. We'll see more applications using multiple database types, a polyglot persistence approach, choosing the best tool for each specific job. Serverless architectures mean NoSQL databases will automatically scale as your application grows without you needing to manage anything. And critically, AI and machine learning are driving huge demand because NoSQL flexible structure makes it perfect for handling the massive amounts of data these applications need. Finally, we're starting to see NoSQL being used at the edge closer to devices like IoT sensors, which reduces lifetime dramatically. Thank you for watching.